Alright, here is our block diagram for the final demonstration. We'll talk about our inputs here. This input is from our heater sensor. The analog voltage comes in, and this one is for our ambient temperature. Both of them go through the same formula based on the data from Lab 4. It has to do with the y-intercept of 811 millivolts and our slope of 0.00412. It's actually a negative slope, but we recalculate it to output the with the negative here. And then from there, the two are compared. Right here, we subtract the ambient from the hot, and then that is sent here and is compared to our offset. And then if our offset is greater than, or let's see, I'm sorry, we don't subtract the offset. We do offset if it's greater, if the difference between the two is greater than or equal to our offset, then we have 0 pulse width modulation. If it is not greater than or equal to our offset, then we get 0.75 or 75% duty cycle to our pulse width modulation. Our pulse width modulation then comes out of the myrio, and then we have a monitor for our pulse width modulation just to see when it's on and when it's off, and that comes back into the myrio, and then we graph it. So yeah, and then here we just have indicators. We have a chart for heater temp, so we can track temp, and for the error, it's easier to calculate for the system response by charting the error and then actual temperature readings. So we'll switch to the VI, and then we'll go ahead and run it.
Run. Frequency at 1000.
Okay, so right here you can see our ambient temperatures varying between 24 and 27 degrees Celsius, and our hot temperature is at 27 degrees Celsius, so that is accurate with our 0 offset. So you can see now our pulse width modulation is at 0, our error is at 0, and steady at 27 degrees Celsius. So if we increase the offset, go 2, there we go, or 3, and you see that pulse width modulation now turns on, and you can see our error is starting to change. We're at 3, and this will slowly go down to 0 as the hot temperature is raised. It's actually kind of slow, so. Okay, yep, see now we're about to a 1 degree offset, or our error is at 1. When we're at 0 is when our offset is achieved.
Should I lower the offset back to 0?
You can go to 2. It should go a little faster. There we go. So you can see ambient temperature is 27 degrees Celsius, hot temperature is at 29 degrees Celsius. So our error is at 0. Pulse width modulation is now turned off. And then anytime the temperature changes, the pulse width modulation will come back on, just like now. You can see temperature started to drop on the heater. Okay, we found that 1,000 hertz or 1K, 1 kilohertz was our optimal frequency. Anything higher and the system would respond too quickly. Anything lower and the system just plain wouldn't respond at all. Couldn't get enough current in our heater to accurate. Just want to show the schematic.
This is our circuit board.
Ambient.
And this is our heater.
So that's our heater
sensor,
and the heater is that little resistor right there.
47
using a
ohm.
47 ohm. Yep. Everything's powered from 5 volts from the Myrio.
That's it.
You